And we're finishing this last segment of the day about GraphQL and GraphQL technologies with one of the biggest advocate and community advocate of GraphQL over the last few years, which is Jesse Martin. Hi, Jesse. How are you?
Hey, Mehdi. How's it going?
Yeah, I said one of the biggest advocates, right? But you've done your part, right? So it's important to notice it, with conferences and with events and with content. So yeah, we're really glad to have you for GraphQL's second act, A Practitioner's Tale. Thank you very much.
All right. So should I just go and get started then? I guess that's my cue to get started. Well, thanks, Mehdi, for the welcome. I don't know if I'm one of the biggest advocates in the space, but I have been around a little bit in terms of one of the longest in terms of advocating for GraphQL specifically. So who am I? Currently a sales engineer at Hasura, specifically targeting the EMEA region. I've been a GraphQL educator for over the last 5 years, really specifically on the technology itself. So what we're going to see in today's talk is actually, when I say a practitioner's tale, it's really my observations of talking with customers and seeing sort of where the puck is going. Aligns a little bit with the company that I'm currently at, but mostly it's actually what I see happening. So that gives you a little bit of context. I have a background in more of the branding, strategy, consultants kind of side, so that sort of taints a little bit of what I'm going to say, or flavors it depending on how you want to call it. But yeah, that kind of gives you sort of the context. I'm also a dad. I got 4 kids, so if I ramble a little bit, apologies. If I drop a dad joke, no apologies, but there we go. To understand a little bit about my current context of when I'm talking about GraphQL, we need to understand a little bit about my current employer. So Hasura is an open source engine that is allowing you to convert GraphQL into underlying data sources. We're trying to see where GraphQL can be used as sort of a normalized data layer, if you will, where you could say across SQL, across REST requests, across all different kinds of data sources, maybe I can just use GraphQL as sort of a normalized language to be able to access different kinds of data, something that we're going to get into a little bit later on. And so what it has a lot of the different kind of functionalities you would need, but I'm not supposed to give a vendor talk. So I'm going to kind of just jump over this really quickly. Essentially, think of it as a tool that normalizes data access across different tools, sitting somewhere here in your stack where you've got essentially your different data sources connected to it. And it allows you to work with your databases, your clients, your microservices, and whatever else. Yes, I said microservices because we're going to have a look at that point a little bit more specifically. This talk is a little bit of a response to some negative motion in the community that I really want to clarify about. Yes, GraphQL can do a lot more than a lot of people think. So stay tuned. And yeah, so if you're kind of curious about what I mean about it being a sort of a converter, kind of works like this. Incoming GraphQL query converts it automatically for you into what the underlying data source needs, in this case being SQL. So gone are the days of writing resolvers by hand. We do this stuff for you automatically. I have talks on that topic if it's something that's more interesting for you, but yeah, fun stuff. A lot of companies use us. Fortune 500 companies, big players, lots of people. Has an open source core, which is great. So if you're wanting to have a play with it, go ahead and have a look. But it's definitely something that's getting a lot of validation in the community. So anyways, that's who I am. That's what the company is. But today's talk requires you to have requires two assumptions to be made. One is that you all know a little bit about what GraphQL is. I'm hoping that's true at this point in the history of GraphQL, as well as you are aware that people on the internet get angry about silly things, because this talk is a little bit of a response to some of those silly things. Namely, those things are going to be that the second point on this slide, and that is that GraphQL is not just for front ends anymore. And that's mostly because GraphQL is sort of becoming a data SDK, if you will. Once you've connected all the pieces to your GraphQL API, you now have this normalized SDK across all your different data sources, and that's a really powerful way to build. something that we're going to go ahead and have a look at why that is so powerful, and hopefully gives you the desire to try it out, that pattern for yourself. Okay, so again, this is a practitioner's talk. So strong opinions, loosely held, but strongly inferred from my experience, or the short version of that is haters going to hate. So let's go ahead and have a jump into this. I'm going to start with two bold statements as generalizations. I'll try to explain those a bit more in specific. I'm going to rush through these slides because I have a 30-minute talk in 20 minutes for you. But basically, statement number one is if we're going to look at REST versus GraphQL, REST is preferred by single service providers, and GraphQL is preferred by multiple service consumers. And we're going to have a look at where this actually comes from. And it is derived from the fact that if you look at modern data access challenges, then you're going to see that there is a plethora of different ways to connect to your data. You've got SDKs, APIs, ORM-driven development, all kinds of ways that people are having to learn to access this data. And so if I'm trying to connect to a REST service and my database and use some sort of evergreen technology through an ORM platform, my developers have to learn a whole bunch of technologies to be able to access, provision, and work with this data in a really annoying way. And the ideal use case that I would like to have is like, what if I could just sort of have all of these different data sources connected through a single access point? Like, what if I just had to learn one entry point to be able to get to my REST APIs, to be able to get to my microservices, to be able to get to my databases? It would be really nice when I'm trying to build out today's modern complex applications if I could just simply have one entry point. And that's kind of the picture of where GraphQL rises, because when we're talking about REST, it's really easy to model this around deliverables, because I can say this is the endpoint and this is the payload. Like, I get a specification, I'm able to say this is what's supposed to be delivered at that endpoint, and done. Like, you hit that path and this is the data that gets sent, and here's some documentation that explains that to you. But when it comes to the GraphQL space, I have lots of different data that's changing in terms of when I'm consuming things. And it's much easier to model around the different dependencies of data that I actually need. So if I'm going to be building out a product, maybe I want to actually say, these are all the different pieces of data that will be at some point needed in this process. And I would like to be able to design a single API that allows me to essentially make that request. And we see REST trying to emulate those kind of behaviors as well, using things like sparse fields or whatever else. This is a functionality that consumables are wanting to have, sort of that shopping cart analogy of getting data as you go down the aisle of product delivery. Now, I am using the word model here very specifically because if anybody has actually tried building out a GraphQL API and building out sort of this general data layer, this is a lot easier said than done, going from the whiteboard to the actual implementation. There's two totally different things in GraphQL land, and those are some of the problem spaces that companies like Hasura and others actually are trying to solve, is to make it less painful. So the value here of when we're talking about connecting all the data pieces as designing out a consumable-based pattern is sort of what I like to refer to as Metcalfe's law for GraphQL. And if you're not familiar with Metcalfe's law, that basically means that the more nodes you have in a network, the more value the overall network has. So if you're talking about GraphQL land, well, actually let's have an example. Look at this here. Let's go ahead and just imagine we had these three totally random nodes inside of our network, right? We have users, coffees, and scooters, which essentially have zero relation to each other, or maybe some, they're sharing a user edge. But if we start to build out this model, we start to enhance it with some more nodes, and we start to draw some of the connections between these nodes, suddenly we actually can see that if I were to write a query or somehow be able to use all of these edges together, I might actually get like a recommendation engine, right? Like I could say, hey, if you're charging your scooter by my coffee shop, you get $1 off from whatever thing this is, or you've bought 5 coffees in the past, charge your scooter here, whatever it might be. I could come up with some kind of crazy business model that makes sense by connecting more and more nodes into a graph. Again, talking about data consumables. And that's not just theoretical, right? Because if you're talking about all the different pieces of endpoints, weather APIs and everything else that would be needed to actually execute on this, this is what the Hasura interface looks like here. But let's zoom in here on the query. Like, this is really much more attainable for my developers. They're able to see the pieces of data that they actually need to access through these edges and relationships of this graph. Now that changes entirely if I'm doing payments or if I'm doing other kinds of functionalities. This is something that becomes really, really powerful for my developers to work with. I've normalized all these different data access points in a way that my developers are able to build quickly and effectively. So super powerful. And some of the key benefits of this is that there's generally less overhead for orchestrating the services. I've got a single entry point, all my nodes are connected, and I've been able to provision, secrets and manage all of the different governance layers at one location. And now my developers don't have to worry about any of that. They can just work with the information they have in scope. Oops. I have a smaller control plane overall, which is actually great for security because I'm not having to expose a lot of services and like having to expose my secrets and credentials in each microservice as I go. I have a reusable pattern. I can implement this again and again and again, no matter what it is I'm building with. And frankly, it's totally agnostic to consumers. And that last piece is the one where people seem to have an issue with, is they want to say, no, the consumer has to be a front-end application, or it has to be a mobile application. Some people even go so far as to say. And I'm saying, no, this idea of data dependencies is really interesting. Let's have a look into this data dependency term and see why this potentially does not need to live just on a client level. So some example diagrams here. Let's talk about a typical federated GraphQL service pattern, standard e-commerce kind of thing, right? So you've got queries in blue, mutations in red, and you've got users, orders, and products representing SQL or REST APIs, whatever else you want on the one side. And then you've got a bunch of microservices or other REST APIs for backing up your mutations for things like logging in, logging out, purchasing, or edits. But if you look at this, there's a dependency that purchase has that actually needs to be accounted for. Because if we go ahead and actually look at purchase specifically, well, purchase actually needs to read from user, order, and product. And so what if I could just use that same API to be able to say from inside of purchase, I'm going to step out, grab user, order, and product, and pump it back in? Like, why not? But in the modern system, we're not allowed to do that. Like, we have to say, no, actually, you have to jump back out to REST land. You have to jump back out to the traditional data access patterns from inside of a purchase microservice. You need to go back to the getting the user, then getting the orders, and getting the products. You're not allowed to actually leverage the same API shape. Like, wouldn't this be just a lot cleaner and a lot easier for my developers to be able to work with? I argue it would be, and a lot better, because this is just a way that we're actually used to designing. I mean, going back to something a bit more or less abstract here, let's say you've got a realistic product here shaping a financial product, right? You've got a whole bunch of different network credit average and pending purchases. You have a whole bunch of data dependencies that you're trying to do for a risk assessment on a specific product you're building. And these are all representing like realistic, like, you've got REST, you've got SDKs, you've got more microservices, and you've got maybe raw SQL reads. Why would you force your developers to have to go back to individual REST implementations and SQL calls and everything else from inside of each of these microservices if you already had them connected and the value of the graph was already in context. Like I could just reutilize the same work from inside of these microservices. And to be totally honest with you, this is actually a very real pattern that we have seen that spans every vertical you could imagine. Multi-tenant applications, real-time telematics, DORA metrics, healthcare, finance. This is something that a lot of developers are starting to see that, hey, once that connect to the world, I should be able to just kind of access this data. Now, I'm getting a little tight on time here, so I'm going to kind of rush along, but some of the dissenting opinions, again, everyone's allowed to be wrong, to using this approach where we talk about just utilizing one graph for all of your data access patterns, is, starting off with, it's not what GraphQL was created for, right? The pattern and the history of GraphQL was designed for mobile applications trying to optimize data payloads so you're not overfetching data when you need it. Right, that's not what it was created for, but it wasn't exactly what it was designed for. So you're actually able to utilize this pattern for accessing your data in a much more efficient and effective way, because the idea was about getting custom payloads in context where you needed it. That's a design problem. What about latency? So there's a question about whether or not this introduces new latency as you're creating some more round trips. And again, if you're talking about any kind of enterprise grade API platform, the reality is this is only marginally slower than the most optimally tuned REST alternative available, right? If you're talking about really like fine-tuned, high-speed data access patterns, yes, there will be some latency here. But I've seen a lot of the architectures that people are building, and frankly, we're talking about gateways within gateways, and this is not actually any slower than that. So what are the gotchas about this pattern, about using microservices, using GraphQL within microservices as well as clients? There's no gotchas. So end of the talk, I'm just kidding. Latency is actually a real one. So this is something that we're trying to solve with Hasura. Everybody's trying to make this be better. A lot of caching utilities and things coming out in that regard. GraphQL on the edge is a really fascinating space. So yeah, latency is a real thing, but it's something that is a solvable problem. And then new APIs will have new problems, right? So things that we solved in REST land a long time ago, we're having to reinvent the wheel in GraphQL land. But again, these are all things that are solvable problems that actually companies like Hasura are dedicated to solving. Specifically, speaking about what Hasura is doing to try to move towards this space, we're talking about API design very quickly. We're shifting ourselves to thinking very much more about model-driven in terms of API design, where actually the backing data services become secondary to your overall shape. That allows you to be 100% declarative, where the model is going to be defining your actual data affordances, like what you can do with the data. And so you'll be able to have a really declarative structure to what you're designing your data shapes with. And the model defines its relations and shapes to other pieces inside of the network. So you're able to say, let's talk about these nodes at a really fundamental level, and then whatever happens to be the best fitting storage pattern behind that, well, you'll be able to tell us where you're storing your users or your scooters. And to be totally honest with you, this approach with model-driven is going to essentially become GraphQL agnostic. If there's another graphy-like API structure that allows this interconnection of nodes in a more performant way, we can shift to that, because what we're talking about is model-driven, because the tooling is what's going to be converting a model to an API, where the model and the API are actually completely independent upon what you're trying to do. So it's kind of what we've been doing actually all along, a little bit, but I know I'm a little bit out of time, and frankly, this is a talk they said that I wasn't allowed to give, so I'm going to stop it from there. But I did give this talk for API Days in New York. So if you don't go back and watch the YouTube videos from the API Days community, there's so much great content out there that they put up on YouTube, like years of data probably at this point to go back and watch what's out there. So if this whole topic about model-driven APIs is interesting, check out API Days New York. I did give a talk on that. So where can you find out more about this general topic on using GraphQL and microservices, model-driven design, and shaping everything. Obviously, you can find it from any of the Hasura properties, as well as just reaching out to me directly on Twitter. I'm always happy to answer questions in DM. And that is it for my talk. I'm a little bit over, but hopefully not too far. And yeah.
So let's go for some queries, right?
Query.
Now, I have a question for you. Like a lot of people say it won't scale. A lot of people say it won't be secure. A lot of people say it will be not possible to really version. It will not be possible to monitor GraphQL queries. Let's say a lot of things have been said. API GraphQL is killing API design, right? So many things that has been shared by people, thinkers thinking the long term of GraphQL. So after 2015, the official, after 8 years, right? I think it's 8 years. It seems it overtook all of this. No?
Yeah, every time there's been a new complaint, and they're fair ones, totally like fair things. Again, we talked about what things we solved in RESTland a long time ago came from real needs. GraphQL has had a way to answer each of those. Sometimes it's a little bit of a different way. Like when it comes to API governance, well, everybody's saying, well, we need to look at the individual fields. It's like, well, to some extent, but maybe there's something different here where we're looking at the request of data, the client requesting that data, and actually your database utilization underneath. Like in the Hasura pattern where we're converting GraphQL to SQL, the fields are less interesting because you can remap those and rename those, but what the actual data utilization underneath mapped to that request becomes more interesting for me as a cloud ops guy, because I can say, well, this query is actually doing a sequential scans across my entire database, and that's bad. And I can figure out how to optimize that. And I'm not having to spend a whole bunch of time fine-tuning fiddly little bits of glue code. I'm just able to say, no, query this in a different way, or add an index here, or whatever else. And then the in-between part solves itself.
Yeah, no, it seems, technology and imagination came to answer to all the questions, right, over the time. Also a question about GraphQL adoption. It most of the time GraphQL is loved by developers and not so much loved by architects who prefer RESTland, as you call it. Do you still see that shift, or let's say the alignment between developers and architects about GraphQL ability to stay and scale over time? Is this a split still?
I would say there's actually a split with architects. There's a split with architects, right? So you've got architects who design APIs are frustrated by GraphQL sometimes because it changes what they're having to do. Architects of product, people who are trying to build out the payment platform, people who are trying to build out the data networking layer or whatever for a massive company, love GraphQL because it's allowing them to think about models inside of a system, which is what people loved all along. They loved the design driven, they loved the object oriented. The problem was the tooling just really was terrible, and it was never a scalable solution. So if you're able to say, give me models, I'll give you an API. Frankly, for an architect, that's fantastic because that allows us to really focus on the things that we really enjoy doing and not worry as much about the details, making sure they're covered, of course, but that allows us to be able to focus on the true design of our architecture, and then making sure that the other pieces are covered, like security, governance, and so on.
Last question about the production aspect. It seems on production it can save a lot of resources, by solving the overfetching, of REST and many other things. But the scalability on large organization, where people used to say GraphQL works only if you know the users. So if you really control the client and the server, to be sure that people know what they do, versus one API in the wild that people can discover and use, not knowing why it has been designed for. Is it still valid or not?
That's valid to an extent, because I differ a little bit from my employer in this regard, that I'm not a huge advocate of saying that GraphQL is awesome for public APIs. Public internal APIs, sure, where you're saying, okay, inside of this massive corp, you're able to go ahead and say, this is the data available for building with, and building on a catalog on top of that. I think that all makes sense. But if you're saying I'm Stripe and I'm just exposing a GraphQL API for everybody to consume, that's getting really challenging. There's solutions for that for sure, but that's an area where it would be a good question to say, whether or not REST is potentially a better solution there or not. And I think that's, again, if we're talking about models to any API, that's solved by that pattern, because you could say, well, in this case, this should just be a REST API, not a GraphQL API. Maybe. But I do think that for publicly exposed APIs that are available for anybody to go out and build with, if I'm making a weather API service, for example, there's a valid question there whether or not that's a good idea, that you'd have to really think about some additional tooling that you would need.
Perfect, JC. Thank you very much for answering all these questions, all these queries, actually, as you asked. And see you at another apidays conference.
For sure.
Bye. Thank you very much for being with us. And now we'll continue with the pragmatic GraphQL patterns with Richard Shan. So, Richard, are you able to join us?
Yeah, I'm here. Can you guys hear?
Hello, Richard and Antoine, right?
Hey. Can you hear me?
So, yeah, we can hear you. Actually, we hear you, but with a low volume. I don't know if you're far from the microphone or.
Well, maybe I need to speak louder.
Yeah, maybe. Perfect. Okay. Thank you, Richard.
All right. Thank you, Mehdi. Thank you for the introduction. Hey, good evening, good morning, good afternoon, depending where you are. Thank you for joining this session. Today, we're going to talk about the GraphQL patterns. So this is a list of the topics we're going to hit today. We start with some fundamentals about GraphQL. We look at the current state, look at some of the challenges and the barriers we have today. Then we introduce a pattern approach. From there, we drill down a specific module in the pattern model. Then we talk about some of the guidelines and best practices. So let's start with what is GraphQL? If you were in the last session, probably I can skip it very quick, right? The big difference for this one, maybe I'll show you this difference, right? On the left side, that is the traditional way we write a SQL query, right? We look up some fields from a table. On the right side, you can see it's much simpler. You specify a particular entity, then you put the attributes what you need. Why do we use GraphQL? Obviously, I think last session, the presenter also talked about some of the benefits. Essentially, it reduces complexity. And also the schema helps to check, what kind of elements, what kind of type. No overfetching or underfetching. This is critical, right? A lot of REST APIs, you have to live with what is described or prescribed. You cannot change here. You can selectively say, hey, give me part of it, right? And which saves time and the network bandwidth. There's some other advanced features that really, the traditional REST API does not provide. So in the diagram, you can see it's, with the REST API on the left side, it is a little bit, complex. On the right side, it's much simpler. You have one endpoint. Then obviously the handler you need to implement, but in terms of the client interaction, it's much simpler. Now let's take a look at the current state of the art. This is the literary extract from the State of GraphQL report published last year. So one thing is the usage. You can see almost half of the developers are using GraphQL to exposing some APIs for personal website or applications. 40% of them are using GraphQL for internal usage. Then in terms of client, 62% are from the browser. Next, we look at the sort of like a backend. 55% of the GraphQL APIs actually hit the databases, while 35% are using the existing REST APIs. And predominantly, GraphQL used in programming. literally, you have these professionals, doing some coding and provide some resolvers and all these kind of logic, enable these GraphQL, and then break down into some other sectors with the numbers here. So with that, what kind of challenges we have? Again, this is from the State of GraphQL report, and you can see it lists some kind of a top headaches, right? Error handling, how does it perform well or scale well? What about the client-side caching to do it? Security, of course, versioning, file upload, and some other pieces. So with that, you can see, it is not overly complex, but, there are a lot of, I would say, obstacles that as a team, as a developer or architect, we have to address these concerns. So we advocate a pattern approach. Now, what is a pattern? In the IT world, a pattern is a reusable solution to a common problem. In other words, this kind of issues have been recurring in different contexts, but they have sort of like common characteristics. So we can try to, leverage some best practices to tackle them in a systematic fashion. Just to let you know, pattern is not a solution or product you can just, deliver. Rather, it's sort of like a template which helps you to speed up or address the what kind of concerns, what kind of issues in a more programmatic fashion. So a good example is a book, 23 Design Patterns by Gannon Ford. So if we count today, it's almost 30 years. That's a seminal work, these four gentlemen did. Now, why do we need patterns? It has a lot of benefits, highlight some of these things here. Obviously, it provides the flexibility in design, and also it separates the duties, enhance the scalability, performance, and reusability. In particular, communication and collaboration, because if you use pattern, we literally use a very similar set of vocabularies to communicate, rather than somebody talking these things and we talk about this one, and it's kind of like a gaps in terms of communications. Now, in the GraphQL world, there are a lot of patterns, a lot of things that I would say evolved from old microservices, REST APIs, and even legacy application development, right? So we try to kind of group them in some classification. Specifically, you can see we modularize these into framework, architecture, construct, execution, topology, and schema. So this helps us to literally sort them out and group them together. And in this particular session, we're going to drill down to architecture patterns. So in particular, we'll talk about these 5 patterns: database interface, system proxy, composite service, single endpoint, and native API. So the first one is database interface. So if we look at this diagram on the left side, we literally talk about the client. In other words, whoever is going to launch a request, whether create some data or create an object. You can look at this sort of like, the request from client side. Then this request is hitting a database, which has, tables, system records to, take the request, create a new records, or search for a particular, field for some, let's see, look up the email for my name, right? That type of thing. So what we put here is GraphQL server, which is actually typically bundled with a web server. So from client side, they just talk to a particular endpoint. They don't need to know the details. Everything is handled here in terms of process the request, then resolve the request, then in turn, make the CRUD call, CRUD call to the database. Then, typically when this come back, it is a result sets, right? And you have to pass this one and maybe paginize that and send it back to it. So this handles everything over here in the middle. In the next pattern, we know in the corporate world, we have a lot of existing applications, whether these are legacy systems, maybe even mainframe, kind of like systems there. And we have microservices. Some of these may be monolithic. And maybe, you consume some cloud API like Salesforce, right? So it's a combination of this one. So for the client side, we don't want to talk to this, kind of like a point-to-point. That's difficult, right? Rather, we have the SQL server here. The client keep talking with the way that, designed for GraphQL query or creation. Then this one is literally say pass that request. Then, with this individual, it can, retrieve the data or send a request or even, do some asynchronous way. So this literally over here provide a proxy to existing applications or services. Next one is called a composite service. As you can see the diagram, we literally have these two combined, right? This is what these services you see in the last pattern, and this is the first pattern. So here we literally have this one to kind of combine these. So it can be passed through, which means, if this individual database hit, it go from this route. And if you want to consume mainframe, RCRF, lookup DB2, you go this one. On top of that, this can aggregate these things because, you send a request and the data elements may not write, in one place and rather different places. So this can, literally invoke individual services and aggregate the results and send it back. Now, the next pattern is called a single endpoint. Now, we look at the right side. This is exactly the same as last pattern. But these are kind of like for internal, because if you want to say, hey, here's a client request coming here. How do I authenticate this client? How do I entitle this client to, oh, you want to call mainframe? Or you want to call my SQL database? Or what have you, right? So there's some control needed, particularly from security perspective. So this here we introduce the API gateway. This really provides a single endpoint. When the request coming, it authenticate, it entitle it, it even, kind of meet it, sorting it, and with different kind of monitoring capabilities. Now, further to that, one single API endpoint is not enough for the GraphQL capabilities. So specifically in GraphQL, we have queries, we have mutations, we have subscriptions. So in that case, you only have one endpoint, it will not fit well. So this is sort of a from very simple single endpoint to break down into different groups. And also in terms of the subscriptions, you cannot do the traditional kind of like we call the request response blocking call, because subscription actually is event driven. So you need some asynchronous way to do that. And from that perspective, the last pattern is only applied to some simple use cases. And we really need these kind of like different endpoints, but not as many as, previous, the pattern number 3, but group them in similar fashion and then provide the, even some discovery capabilities, cataloging, API management, and governance over here. Now we talk about these 5 patterns. Now the next thing is how we can use them, right? So in this chart, we list some pros and cons for each of these we discussed. So the first one, it's very simple to implement. So if you start from scratch to build some GraphQL capabilities, this is the way to go. On the other hand, it is tied with a particular database, depending on what you use. And you have to look at whether it's a connector to the database or you build your own resolvers, things like that. Second pattern, the good thing is, existing systems, applications, you literally can reuse them, right? The people don't need to know how do I interact with them, what is the port, all these things, right? So no change to the existing services. You can, maximize the reusability of existing applications. On the other hand, whatever the constraints in the existing system, you cannot change it because that's the, naturally, that's what it can provide. And also, if you want to add some new sources, like new data source, new stream, it cannot do it. Certainly, this one is composite, right? So the good thing is kind of like the best combo, right? Leverage the best of the first one and second one. And secondly, this is the path to increment the sort of migration, because some of the existing system you want to refactor it, you want to re-architect it, then it takes time, right? Rather than wait for a year for us to move all these things, you can say some of these let's expose this one, let's hide the complexity. So that's the benefits for very fast migration of older services. On the other hand, barriers of the existing system that's similar to case number 2, and also the complexity when you want to do some aggregation of these things, and sometimes because of the incompatibility of the different data elements, it will create I would say challenges to us. Now the first one, we just say, okay, yeah, rather than expose all these GraphQL APIs, hey, we want to manage some security entitlements, the authentication part, right? And also you can meet it, you can sort it, and you can monitor the consumption and whatever, maybe setting different tiers if you want. And the downside is more complex since you add the API gateway, and also cost of it, skill set, you need to maintain that. The last one is the native API, as we mentioned. The good thing is literally provided all these GraphQL capabilities, queries, mutations, subscriptions, to the consumer side or the client side. And it generated the specific endpoints for the consumption. On the other hand, the complexity is the max, right, among these 5 patterns. And also, if you want to implement the subscription feature, need a multi-steps. It's not straightforward. Hey, go to API gateway. Let's implement. So on the right side, there's some examples listed over here, which shows you, hey, for this specific pattern, you can leverage some open source products or some vendor commercial out-of-shelf services to implement these patterns. So next one is, we kind of understand the pros and the cons, right? But still, you want to see how do we select, right? So this is really up to the scope of the project. Over here, I just show you the very simplified version, right? For example, if we start from scratch, it's a greenfield project. Database interface is probably the most viable thing to do. And if you start with brownfield with a lot of existing assets, services, APIs, applications, then use system proxy makes most sense. Then if it's a hybrid mode, let's break down if it's internal use inside of your team or inside of your group. Not too many controls you need to apply, then use composite service. On the other hand, if you have some partner usage, you really want to apply some entitlements, control, API governance, and you probably single endpoint is the best fit. And the last but not least, if you're doing some customer facing and you want to use the native API pattern to fit the bill. So next is about how do we apply this? Now this is kind of extract a little bit. We talk about this particular architecture patterns, right? That's just one part, because we look at the GraphQL application or service development, it's a life cycle. I kind of simplify with 6 stages: discover, define, design, develop, deploy, and deliver. So each category or each stage will build patterns. That's actually, as I mentioned earlier. Then, in general, some guidelines, right? How do you apply these patterns effectively? You need to define these data types very well, structure. It's ideal to decouple front end from the back end so you can separate the duties. Create a schema to define APIs, use tools to validate your schema, and leverage tools to kind of like generate the kind of code automatically once your schema defined. So the client side do not need to do it from scratch. Test it well, query the relevant object in one single call. But even though I know, right, GraphQL is much more efficient, avoiding overfetching, but you still sometimes you want to say, let me combine these things to, rather than, chatty talk to the server side. And also use a pipeline to automate the deployment, handling the error consistently, and manage the permission. So some of the best practices, understand the problem well. And this, I think, is very general, right, for different types of applications. So I put some kind of like a checklist of what kind of question you should ask. You should drill down to kind of like fully understand what exactly the problem we're dealing with, what kind of, the hidden things, what kind of assumptions, what kind of dependencies. Second one is take the best approach. As we talk about the patterns, there are a lot of these, right? And not necessarily one is the best. So a lot of times you actually have to do the trade-off, right? Hey, let's compare these, and how do we weigh different benefits as well as the cons, and figure out what's the best approach to do it. Then plan out the ownership, because as you look at the GraphQL, it's a multi-party. There are a lot of things, client side, backend side, database side, API gateway side, and really you want to create a RACI chart. So everybody will be on the same issue. Who is accountable for that? Who is going to implement that? Who is going to verify that all these things. And the last but not least, GraphQL is not a silver bullet. We don't expect that this will solve all these, integration issues, right? But, when you apply this one, look at, what kind of values it add, focus on low-hanging fruits, get something built out. Then, it can evolve, right? So see, build on top of that, what do we need to do? And a quick recap over here, we talk about the fundamentals, look at the current state, we talk about the obstacles we have, and then we advocate, taking pattern approach, we drill down to architecture patterns, we discuss briefly about some guidelines, and last but not least, we kind of elaborate some of the best practices. With that, I'm going to hand it back to Mehdi for some questions.
Hi, Richard. Thank you very much for this presentation. A quick question about the different patterns that you present. It seems some patterns are a real fit for GraphQL, and from what I understood, some patterns are kind of adaptation of GraphQL to this pattern, right? Or do you recommend all these patterns to be fully effective with GraphQL technology?
Yeah, I think it's a mix. Great question. So the patterns here, we call it dependent libraries, and it has a mix of the patterns that kind of evolve from the old microservices, REST API development, or enterprise integration. But they are kind of like a little bit modified to adapt it to the GraphQL domain, because there are different contexts. And there's another set of patterns that are very new or native to the GraphQL that do not exist, those problems or issues in the traditional way. For example, schema, right? Resolver, that type of thing, or schema stitching. Those kind of patterns, they don't exist in the previous world. So we have a mix of this one combined together.
Yeah, okay. Interesting aspect. Also about the adoption of these patterns. Do you see any pattern today which have more adoption than the others, or that is easier to adopt by starting companies with GraphQL? Yeah,
in terms of adoption, I think I shared the state of GraphQL report, which published every year. I pulled on the last year because the latest had not been updated. So from that one, it's kind of provided the kind of like survey how people feel about it, and I can clearly see because this report has been, I think it's more than 5 years, right? The gradual growth, the steady growth of adoption of GraphQL. In the meantime, a lot of new challenges as people working on this one. So I would see from good side is the adoption rate is there. I think a little bit accelerating. And also people are more and more leaning to using this one to see the benefits, right? Rather than the old way with the monolithic API, with the microservices that's too heavy. And the REST API is light, but it is chatty. You cannot change that type of thing. So I think it is there. On the other hand, I think another big challenge area I think is for community, as really like this forum, right? to advocate the usage of the patterns, advocate to literally to speed up the learning curve, right, for the teams. So they struggle on this one. Then if you use pattern, it will save their time rather than understand like introspection. How can we use it? Where do we use it? Right, that type of thing. That's what we advocate, using patterns to shorten the learning curve and speed up the adoption in a faster way.
Perfect, Richard. Thank you very much. We reached the time allocated for your talk. Thank you very much for this presentation and actually describing all these patterns in a way that are that really explain the difference and which fit for which use case.
Thank you.
Thank you for that. And we'll finish, last but not the least, right? We'll finish with Antoine and Tristan from Escape, right? The rising star of API and security and GraphQL, graduated from Y Combinator, raised their seed round, just got like a trophy from Les Assises, right?
Absolutely. Yeah, exactly.
One of the top security conference in Europe, right? I don't know if we can say it's the DEF CON of Europe or the Black Hat, because it's more enterprisey, a lot more enterprisey.
Yes, absolutely.
It's the RSA. Let's call it the RSA of Europe.
Yeah, absolutely. This is exactly that.
One.
Yeah.
So congrats, and you had a great study on GraphQL vulnerabilities. So let's dive into that, and you have some time for that. So yeah.
Great. Thank you, Mehdi, for having us. Glad to be here today or tonight, depending on where you are in the world. We are Escape, and we are here to present a study about GraphQL vulnerabilities in the wild. So with a powerful language comes great responsibility, and in particular, the responsibility of securing it. And we did a huge study of scanning real-life production GraphQL applications on the internet, online. And we're here to present what we found and what it told us about securing GraphQL in production. So let's start and let's dig into that. First, a little bit about Escape. We are a company. We are the first automated security testing platform that is actually able to test the business logic of APIs, and more specifically of GraphQL, because we started with this technology, which we like a lot. So for this study, we scanned more than 1,500 production APIs for trying to finding security vulnerabilities. It took us more than 400 cumulative scan hours. So that's a huge AWS bill that we have for producing this study. I hope you will like it. And we found a lot of vulnerabilities. We found more than 46,000 security alerts on the production GraphQL endpoints. That's more than 30 security alerts per GraphQL app on average. So we can see there is a huge security problem in the production GraphQL apps. The result of the study has been published on a full featured report, which is called the State of GraphQL Security. If you want to check it out to have like the full statistics and the full results, you can feel free to check it out. I'm Tristan. I'm the co-founder and CEO of the company, and I'm here tonight with Antoine, my co-founder and CTO, and he handles the tech and product part of the company. And I will let him start by explaining why GraphQL is specifically vulnerable to cyber attacks in production.
Thank you very much, Tristan. So yes, as you mentioned, as a CTO, I'm here to handle the technical stuff here. So let's start with technical things. So the first thing that is really important to understand here is why is GraphQL so vulnerable? The first thing is that GraphQL is currently used in production by companies in every Fortune 500 verticals, in retail, finance, travel, and so on. And mainly thanks to its amazing federation capabilities that allows it to combine multiple API sources together, from whether they are from REST, GraphQL, or other kind of APIs. GraphQL indeed is an amazing language, but with great features comes great responsibilities. And indeed, in that case, every single of these features that are in this slide, such as operations, fields, directives, parameter analysis, and so on, they also come with a potential source. They are also potential source of vulnerabilities for GraphQL, of course. In addition, GraphQL is a graph which is connecting resources together. In particular, one resource can be accessed by an unlimited number of different paths in the graph, which make access control very, very difficult to ensure and to manage in GraphQL application. Okay. So the second thing that is really important to understand how we came to this report is how did we manage to get all of this data from GraphQL endpoints, and why is it hard to automatically assess GraphQL APIs from a security point of view? Okay, so if we just send random cybersecurity payloads on APIs, obviously the request won't pass the validation layer, and therefore we could not test any business logic of the API, and especially from a cybersecurity standpoint, this will make nonsense. That's why we developed a unique technology, which is called feedback-driven API exploration, which is able to generate legitimate traffic on GraphQL API. It does not require any agent nor traffic capture, and thus it does not endanger the production data of the customers. Well, to illustrate this, let's take the example of an e-commerce platform with two kinds of users. Imagine you have, obviously, on an e-commerce platform, the sellers on the one side, that on the one hand, that should be able to see the orders of all the customers and interact with those orders. And on the other side, you have buyers that can make orders, but that are not allowed to see, obviously, the orders of other buyers. To test a complex business logic case like this, it requires that the application we test has at least one seller, two buyers, one product for sale, and two pending orders from different buyers. And with our unique feedback-driven API exploration algorithm, we are able to generate the legitimate sequences of requests that can test the situation every time the application is updated by the developers. The second trick here is that, again, GraphQL is a graph. So the algorithm must ensure that we test this condition for all the path and for every single path in the GraphQL application. All right, so have we done with the pure technical part that was, I think, necessary to understand the results that we are going to introduce now? So what did we find? Actually, we find almost 50,000 vulnerabilities into the wild. What is really interesting is that 10% of them actually were of critical severity, whereas we made all of those requests completely on an unauthenticated manner, and everything was accessible on the internet. So here we created a custom alert classification that is tailor-made for GraphQL ecosystem. But here is the matching with the OWASP Top 10 23 vulnerabilities. And very interestingly, we can see three main categories of vulnerabilities emerging here according to the OWASP Top 10 classification. And this is what Tristan is going to explore now with you. Thank you.
Thank you, Antoine. So what we can observe first, if we take a deep dive into the result, if we break them down per classification of the findings, is that a lot of alerts that we found on those results are GraphQL specific. So actually the most common vulnerabilities in this study, the most common security alerts are specific to GraphQL. Let's take a look at the chart. So here is a chart of the amount of alerts with respect to the type of vulnerability that we found. And we can see that the three most common vulnerabilities that we found on GraphQL endpoints are all related to GraphQL specific features and features of the GraphQL language or features of the GraphQL engines themselves. The first one is alias limit. It's like a complexity problem. The second one is directive overloading. It's like a denial of service that is caused by abusing the engine's parser. And the third one is information disclosure through field suggestion. And even in the rest of the vulnerabilities, we can see that a lot of them are also specific to GraphQL and cause denial of service, complexity problems, pagination problems, and so on. So let's take a deep dive into the 3 most common vulnerabilities in GraphQL endpoints, in production GraphQL endpoints, and let's take a look at why they happen and how to prevent them. The first vulnerability is like the ability to brute force an GraphQL endpoint using batching or aliasing. Batching or aliasing are 2 different features that have the same goal in GraphQL. They allow to batch and to launch several GraphQL queries or mutation, several GraphQL operations in the same HTTP call. So they can be used, for instance, to query 3 different person, 3 different users at the same time, or 3 different queries that have nothing to do with each other in a single HTTP call, and then get faster performance. But the problem with this feature is that if it's not limited, it can allow to bypass the rate limiting that is done at the HTTP level. So for instance, say you limit you rate limit the login to 10 requests, and then you stop it. With the batching activated or the aliasing activated, you can actually send as many login requests as you want with different usernames and different passwords, and just bypass the rate limiting and try to brute force actually the login mutation and get the password and the token of an user. So this is a very simple use case that highlights how GraphQL is different from classic APIs from a security point of view, and why it can be exploited in tricky ways to find security vulnerabilities inside of an API. The second one is denial of service. It's a denial of service through fragments. Fragments are a piece of logic that can be shared between multiple queries. It's like a function, but in the GraphQL language. So for instance, here, in this case, we create a fragment name parts on the object person, and that returns its first name and its last name. But what happens if we create fragments that call each other in a recursive manner? Well, actually, some GraphQL engines are vulnerable to it and create an infinite recursive loop that end up crashing the server. So in this case, for instance, it's a Node.js server that is vulnerable to this, and we created this recursive fragment. We sent it to the server, and we were able to crash it completely. The problem with this is that it relies on the GraphQL parser itself, and it's very hard to fix because it does not depend on the custom code of your developers, but rather on the engine itself. So you have to wait for an update of the engine that would fix this problem in order to fix the vulnerability and to not be vulnerable anymore. And the last one that I wanted to highlight is the internal API schema leak. So as you know, GraphQL has a feature called introspection, and this feature allows you to fetch the full GraphQL schema by sending a specific query to the GraphQL endpoint. In specific cases, you do not want to disclose the full schema because it's not meant to be public, and you want to preserve the secret of what lies in your GraphQL API, so you can deactivate introspection. But there is another specific feature in GraphQL that is implemented in most GraphQL engines. It's called field suggestion. Basically, when you do a query with a typo on a field name, the GraphQL engine sends you back an error message that says, okay, did you mean this or that? The problem with this handy autocomplete feature is it can be used to build back the schema by sending approximate or random possible fields and letting the engine tell you what is actually inside of the schema. So this is an example of a real-life situation that we encountered with Escape of a company that closed its schema, but let the field suggestion feature enabled. And we were able, using an open source tool called Clairvoyance, to fully build back the internal schema of the application. And guess what? They had an update admin mutation that was they thought it was hidden, so they didn't protect it against authorization. So we were actually able to change the admin password of the platform just by uncovering the full schema of the application, including the mutations. So this shows an extreme case, obviously, because this is a high or a critical vulnerability. But this shows a practical use case of how to exploit simple features of GraphQL in order to escalate to large-scale attacks. Okay, so we reviewed the vulnerabilities that are specific to GraphQL, but we must not overlook the classic API vulnerabilities because they are still there in our study. So if we take a quick look, we can see that there are a lot of server errors that disclose too much information, stack traceback with a lot of details, and also access control problems, and even some injections or IDORs. So again, access control problems that allow to fetch a lot of data from the API that are exploitable in the wild. So there are still injections, SQL injections, server-side request forgery, and even one bash command injection that are exploitable in the wild on GraphQL APIs. You found injections where I think of the past, apparently it's not. If we take a look, a closer look and a deeper look at what really happens for those specific vulnerabilities, we can see that a lot of endpoints are vulnerable to API errors and information disclosure. So in a lot of cases, the GraphQL server, when it has an error, it sends back a stack trace, which includes the position on the code where the error lies. And this gives a lot of information about the internal libraries that are used by this server. And then it's pretty easy to go into online databases and find the vulnerabilities that are specific to those internal libraries and try to exploit them. So in this case, we can see that this problem shows that this server is using Apollo Gateway 0.6.1. And we can see that this version of Apollo Gateway is critically vulnerable. And we could exploit this in production. Second problem, access control issues. I can't name how many access control issues we saw during this study. There are a lot of endpoints that actually have mutations to update different sensitive data in the database that do not need any authentication token. It means that any user, any public user, unauthenticated, can change actually the state of the database and make complex operations within the API. So this is a huge problem also that must not be overlooked. And finally, as I said, injections are still there. So we found 16 SQL or no SQL injections during this study. So simply injections in GraphQL parameters that were not escaped properly. You see escaped, it's the name of a company. Everything makes sense, right? So 16 SQL and no SQL injections because the parameter were not escaped properly, and one bash command injection on a GraphQL API, and 3 server-side request forgery. So for avoiding this, you must be sure that you validate the input properly and that you escape any sensitive character or special character in the user input. Okay, last part of those results is the sensitive data that we found that was public in those GraphQL APIs. So GraphQL, again, with introspection, has this specificity of letting an automated crawler like Escape and the technology of feedback-driven exploration that we build explore the API and index the data that is publicly available. So we use this technique and we used it on all the different endpoints to see if we could get sensitive data from the endpoint. We found more than 4,000, almost 4,500 potential PII and sensitive token secrets leaks in those GraphQL API. If we take a closer look, there is a lot of PII involved, a lot of emails, and a lot of phone numbers. Of course, some of them might be legit. For instance, if it's a support phone number or a support email, it can be legit to have it publicly, but the amount is so huge that we're pretty sure that most of them should not be there. Even worse, we found password numbers, US bank account numbers, international bank account numbers. So we found all those data that was publicly accessible to any client on the internet that was willing to put time enough to search in the GraphQL API. And about the token, it's even worse. We found API keys, hashed passwords, unhashed passwords, like plain text passwords, AWS tokens, Adobe client, Asana client IDs, GCP API keys, Slack tokens, and even OpenAI tokens. So we found OpenAI tokens in error messages that were sent back to the client when there was a problem within the API. So it means there is a huge lack of best practices when it comes to stripping the secrets from the error messages and from the response of the APIs. And this also must be taken care of. Okay, let's make a pause. Now, if we take a look at this study from the OWASP top 10, the OWASP API top 10 framework, we can see that in GraphQL, there are a lot of denial of service and complexity issues. So GraphQL is a language, it's a graph, it's prone to unrestricted resource consumption by default. You must limit the resource consumption by the GraphQL queries and ensure nobody can exploit the GraphQL specific features to create denial of service or overcharge the server. The second thing is access control, authentication, and authorization. So again, GraphQL is a graph. It has a graph nature, and access control in a graph is very complicated because you need to secure all the paths leading to a sensitive resource if you want to be sure it's secured. So we have seen a lot of broken object level authorization, as well as broken authentication systems, broken object property level authorization, broken function level authorization. We have seen a lot of those, and they are generally critical, and especially the last two ones. And finally, security misconfiguration and information disclosure are done because GraphQL is very verbose by default when it comes to error messages. It sends a lot of data back. It can send internal error messages from underlying APIs. It can send data that is in the cache. It can send data that shows what is the internal schema of GraphQL using development features that are enabled in production. So security misconfigurations are very common, mostly because the best practices are not well spread among the GraphQL developers yet. And we advocate for more best practices for that matter. Okay, so in conclusion of what we found during this study, we found 130K plus public GraphQL APIs into the wild by scanning the whole internet. And we scanned more than 1,500 of them for security vulnerabilities, the ones that were public and unauthenticated. We highlighted numerous vulnerabilities in GraphQL, most frequently GraphQL specific, but also more classic, such as injections, error messages problems, and so on. And we found a lot of access control flows and secret leaks, which are very frequent in GraphQL when you take a wide look, a macro look at what exists on the internet. Okay, so again, if you want to take a look at the details of this report, and especially all the figures and all the different vulnerabilities that we found, you can take a look at the State of GraphQL Security 2023. It's free to download, so feel free to check it out. And now we can talk about two more things that are important to us and that are complementary, we believe, to this study. During the talk, I mentioned that the vulnerabilities from GraphQL came mostly from two different things. One, it is the the lack of proper security configuration. So security misconfigurations are responsible for a lot of GraphQL vulnerabilities that we found. And the second thing is the lack of best practices and the lack of knowledge about the best practices from the GraphQL developers. So we have a few things about this that we'd like to talk about. But perhaps I will let Antoine, because this is his part of the force.
Yeah, no, absolutely, Tristan. What I think is really interesting to mention here is that this study has been made on production-ready GraphQL endpoints that are owned by, I would say, companies with good reputations. And what is really interesting here is that the different best practices Tristan mentions, the vulnerabilities we found, and so on, actually, the responsibility of securing this falls into the developer's hands. And we really found there was a huge lack of tooling for developers to handle GraphQL vulnerabilities at scale. And this is why we worked on 2 open source projects that are absolutely interesting and that help developers fixing vulnerabilities in production, in their production applications. The first one, is GraphQL Armor. This is a completely free and open source security middleware, and we will love you to contribute. And it provides out of the box security best practices for some of the vulnerabilities we presented before, and especially the GraphQL specific vulnerabilities that are related to denial of service and complexity attacks, such as the one that are described here. So maybe Tristan, you want to add a few words on GraphQL Armor?
Yeah. So GraphQL Armor is like I think like it's like the missing piece of GraphQL security middlewares. So we decided to build it because we saw how frequent it was misconfiguration, or frequent misconfigurations, and especially security misconfigurations were in GraphQL. And very quickly we were able to gather developers from the different major GraphQL engines. So it's specific on Node.js or TypeScript engines, but we can see that the Guild decided to come into the journey to help us build GraphQL Armor. Apollos themselves, they decided to come with us and help us build GraphQL Armor and make it compatible with the last version of their engine. So we have really gathered the community around this open source middleware, and we quickly have made it adopted among great organizations. So it's very cool to see the community gathering around security. And the good thing is with GraphQL Armor is that it doesn't impact production. It's designed to be completely seamless for integrating into production and never block legitimate traffic, but just block requests that are obviously abusive, and especially the ones that abuse by sending too many aliases, by sending too many characters, by exploiting requests that are too costly, too deep, underuse too many directives. And of course, we also block the field suggestion, because in this way, if you deactivate the introspection, your GraphQL endpoint will not leak the actual GraphQL schema of your API. So again, if you are using Node.js with GraphQL or TypeScript with GraphQL, feel free to use GraphQL Armor. We really encourage you to try it. It's very efficient, very easy to use. And also feel free to contribute to the repository because we always want to collaborate with the community. So that is
it's a quite active repository, and we just had a great merge request today from Redwood.js maintainers.
Yeah.
So we are quite happy with that, and GraphQL Armor is not downloaded more than 50,000 times a week. So that's cool for a spare project.
Yeah, originally it was a side project that we decided to build in 2 weeks with our engineering team, and it just it just made it through. So that is for the first open source project that we wanted to talk about, and the second one is we're introducing the Learning Center. So this is for the learning best practices part. So we're introducing escape.tech/learn which is a learning center for understanding and practicing the security best practices for GraphQL. It gathers actually lessons from the study that we showed today. So the different vulnerabilities that are more common and how to avoid them with interactive training that happen everything in the browser. So no need to install in development environment. You can
use
just
web containers.
Play, yeah, exactly, with web containers. So it's very it's a nice piece of technology actually, and you can just go and try to play with it. It's very relevant, very useful, and we are adding new courses on a weekly basis. So it will be updated constantly, and we are quite proud of the results so far. And we're looking forward to see you compete for the maximum of points in securing GraphQL. I don't know if you want to add something, Antoine.
Well, actually, again, the project is fully open source. The project is in beta too, and we just released it in beta version. So feel free to open issues on GitHub, and we'll love to improve the project and to make it evolve with the community.
Great. Okay, I hope you liked it. This is the end of the presentation. I will just let the slide. Can I do it?
Yes.
Before we move on, I will just let one last time the QR code for having the full report. If this is interesting for something, I received notification because I see that there are a lot of downloads of it. So I'm glad that you like it, and I will be happy to answer the questions from Mehdi and others.
Totally.
Yeah, thank you very much. A lot of things actually. When we read your report, I have a question for you. Like, after 8 years of GraphQL, it seems the adopters are not completely ready, or at least they're still doing a lot of mistakes. Do you think it's because GraphQL is behind its apparent how can I say that? It seems easy to use, it's easy to consume, it seems easy to build, but actually it has complexity over time that people may not see? Or do you think it's the tooling, or do you think it's just security, people don't get it? Why so many questions?
It's definitely a whole...
I would say it's the last one. I think there is a lot of different things here. I think one of the things is not only that the security people didn't get it, but the bad guys also didn't get it and didn't know how to use GraphQL and how to exploit the specificities of GraphQL. But this is changing, and this is changing fast. We have seen a lot of projects on GitHub that are dedicated to exploiting the vulnerabilities of GraphQL. During this talk, I've mentioned Clairvoyance, but there is also GraphRoof, there is also GraphQL Cub. There are a lot of open source projects that are dedicated to actually exploiting GraphQL. So the security people inside of the companies, and especially enterprise, they are starting to realize that GraphQL is actually a weak point, and that the bad guys are actually starting to notice they can exploit it. So this is why the community in general is getting more and more aware of the best practices and willing to implement them in their production endpoints.
And as mentioned in the pitch earlier, the pitch just before ours, GraphQL is gaining ground. So there are more and more GraphQL used in enterprise companies. So it becomes more and more interesting to try to hack it too.
So bigger companies, so bigger pot. So then attackers begins to be interested by GraphQL. So, okay, more GraphQL, let's say, influence. So more people interested to know what's behind, right? Okay.
Absolutely. It's like more people are having Macintosh. So there are more and more viruses on Macintosh too, compared to how it was 15 years ago.
Yeah, I understand. I totally understand. So it's not about the tech. It's more about like the incentives. It's an incentive problem.
Yes, but there are so few things about the tech due to the fact that GraphQL is a graph, and this causes a lot of access control. This is a nightmare to ensure access control in GraphQL because of this reason that one resource can be accessed by an unlimited number of paths and of deep path, I would say. So it's quite complex to secure too in practice.
You cannot have the good advantage of being a graph and without the bad advantage of being a graph, or the disadvantage of being a graph, right? So totally,
yes.
Totally agree. So do you also see a difference in maturity of companies, like in your report and in your customer base? Like, are more mature companies using GraphQL better than the smaller one, or no? Like we see exactly the same.
I would say that the early adopters of GraphQL start to do well, especially the big organizations that adopted GraphQL early. They generally do better. I'm thinking about GitHub here, Stripe, but even if they do better, they still have a lot of security flaws that they didn't find. So they do better, but they still do not understand to which extent GraphQL is actually exploitable.
Yeah, I remember also other company like Dropbox or Netflix who were using GraphQL like really early 2016 or something.
Yes.
Yeah. Again, coming at apidays to talk about it. So yeah, like top American players, large companies have been, Airbnb also, I remember. So all these companies have been using it for really, really a long time, right? So do you think the tooling ecosystem, except for Escape, right? But do you think the tooling ecosystem is mature enough? Where are there opportunities today to build great GraphQL tooling?
That's a great question. It's a great question. I see the tooling maturing very quickly. Especially, I want to give kudos to a friend from the guild on that matter.
Yes.
They are gathering the community around the project of creating better open source tooling for GraphQL. They're on the verge of succeeding. There is a lot of good stuff coming out of their code bases, and so they're building a lot of exciting stuff, and we're glad to give them a hand sometimes. And so I think like the tooling is evolving very fast, and since we started Escape, a lot of other tools for the GraphQL ecosystem have evolved a lot.
Yeah, we can see that Postman released a GraphQL engine for Postman very recently. So it's evolving. However, we can see that GraphQL still lacks of some toolings for developers, such as it is still really poor from a monitoring point of view. If you don't use, for example, the default Apple solution, I'm thinking about Datadog APM, for example, which is not really handling GraphQL requests and so on. So there is still a lot of work to do on the GraphQL ecosystem, and companies that are building the tooling are currently realizing that GraphQL is becoming a priority for them. And we see a huge motion towards GraphQL in the last month, I would say even.
Yeah.
Okay, so it's even in terms of weeks you see adoption.
Yes,
there is a huge difference, and I've talked with people from monitoring companies that were telling me like 1 year ago or 2 years ago we had about 3% of companies using GraphQL, and now it's 25%. So the growth is tremendous and continuous, and we're glad about that, because we think GraphQL is a great technology that has a lot to offer to engineering teams.
Okay, thank you very much. So it seems we don't have any more questions, but yeah, thank you. And again, if you can put again the QR codes are for people to be able to download the report. So you will I don't know if you will do this report every year, but how we can contribute to the next report?
Well, this is a great question. I think you can submit your API to be tested as well.
Yeah, that's it.
If you dare about putting your API to be tested, but as well, like feel free to contribute to the open source project. This is really what helps the community, and especially the GraphQL community, to thrive.
Perfect. Thank you very much, Antoine. Thank you, Tristan. And thank you for closing this GraphQL segment by production ready GraphQL, and your great report on security issues, at least that you found, and so many others to be found.
Absolutely.
the escape guys are coming. Oh no, they will find.
We are
that's sure.
Thank you, Mehdi, for
Thank you.
having us today.
Thanks
Yeah.
a lot, Mehdi. Thanks a lot, everyone. Thank you.
Have a good one. So that's the end of this segment and the end of the this track. I think the other track has still like few minutes ahead. Just want to wrap up to say that it was really interesting 2 days. Talking about LLMs, talking about API lifecycle management, talking about API security on day one, and on day two, like we had a lot of latest trends like event-driven architecture. We had trends also about like standard specifications, API lifecycle management, API design. We APIs as a product, API business model, so many topics. And we finished by this segment on GraphQL, technologies and GraphQL practice. So again, the slides will be available for the speakers on our SlideShare account. The videos will also be available. Everything is recorded. Will be available on our YouTube channel. You will be able to find everything. If you want to know more about our in-person conference, you can go to apidays.global. So that's where you will be able to find everything about the next conferences. The next in-person one are Hong Kong and London. Then we will go in Melbourne, and then we will finish by our annual event in Paris. Don't hesitate also to apply to speak if you ever dream to speak at an APIdays conference or an API conference, or if you have a topic that you think deserves to be heard because nobody's addressing the way you are addressing it. Please apply. We always love new speakers, first-time speakers, diversity speakers. We welcome everyone to share content with the community. It was a great 2 days. Let's see each other at the next APIdays conference. Bye.